So for this video, we're going to be focusing on parallel lines and parallel lines that are cut by transversals and the angles that they formed. And at the tail end of the video, we'll talk about using information to then prove that certain lines are parallel to each other. And so we want to first start by going over what is probably review, but is good for us to really make sure that we have a good foundation of before moving into some of this deeper content. So the first type of review definition we want to go over is adjacent angles. And adjacent angles are any two angles that share the same side. So in this diagram that we're seeing, we have this pink angle ABC and this blue angle DBC. And these two angles, because they are connected by the ray BC, they are adjacent to each other, creating this bigger angle that is ABD. We also have supplementary angles. Supplementary angles are any two angles whose measure together, the sum of their measurements, equals up to be exactly 180 degrees. Now, if you notice in the diagram, angle 2 and angle 1 are not connected. They're not touching. Supplementary angles do not have to be adjacent to each other. Just the measurements together, their sum, has to be 180 degrees. Now, when they are actually adjacent and they're supplementary, we call them linear pairs. So linear pairs are adjacent angles, adjacent supplementary angles, but together they are forming this connection, this straight line beneath them. So anytime you see a straight line and you see a ray coming off from it, these two angles are considered to be linear pairs with each other. They're two separate angles. Together they form a straight line, and together they are supplementary with each other. And lastly, for our review definitions, we have vertical angles. And vertical angles are any opposite angles that are formed by the intersection of two different lines. So anytime you have two lines intersecting, no matter how they intersect, the angles opposite each other are always going to be vertical angles, and thus they are always going to be congruent. Now, let's take a step and dive into the world of parallel lines. Parallel lines are two or more lines that have the same slope, but they have different y-intercepts. So they travel the same way as they go across the coordinate plane. They travel in the exact same direction, but they are doing it starting at different y-intercepts. Now, as these lines travel, they sometimes come across other lines that go through them, and those lines are called transversals. Transversals are any line that intersects through parallel lines. Now, when these transversals hit parallel lines, they create certain types of angles. There are four main types of angles that are created by these transversals. The first one, if we see that we have this pink transversal going through these two blue parallel lines, the first type of angle that we can recognize is called alternate exterior angles. The reason why it's called alternate is because they're on alternating sides of the transversal itself. For this example here, one angle is on the top of the pink line, one angle is on the bottom. They're alternating. The reason that they're called exterior is because if we consider the parallel lines to be kind of barriers, this would be the inside, this would be the outside. So these angles are on the outside of the parallel lines, and they're on opposite sides of the transversal itself. Now, there's a specific type of relationship between these two angles because it's happening through parallel lines, and that's that they are congruent to each other. Whatever the measurement of one angle is, it's the exact same measurement for the other. And so, continuing with that, you also have something called alternate interior angles. And again, it's called alternate because the angles are on different sides of this transversal, of this pink line. It's alternating. And it's called interior because if these parallel lines are my boundary, these angles are found on the inside space of those parallel lines. And then just like last time, there is also a relationship between them. These angles are always congruent to each other. Now, if we flip our parallel lines and we go sideways with them instead of up and down, and we have a transversal that's going through, the same statement is still true. These angles are alternate exterior angles, and they're still congruent to each other. These angles are alternate interior angles, and they are congruent to each other. So it doesn't matter which direction those parallel lines are shaping or going, these types of angles still exist. The next type of angle that we can look at is called corresponding angles. And corresponding just means that they have the same relationship. So these angles, if we look at them, they're in basically the same kind of spot with each other. They're both on the same side of the transversal. They're both on the right side of the parallel line that they're next to. They're both kind of facing outwards in the same direction. Everything about them is the same. The only difference between them is that they're not in the same spot. They're in different spots. And so because of this, corresponding angles, like the last two sets of angles, are congruent to each other. So all of these angles so far have been congruent. Alternate exterior, opposite sides of the transversals facing outwards. Alternate interior, opposite sides of the transversal but facing inwards. Corresponding angles on the same side of the transversal but facing in the same direction. They're not facing each other. And so the last type of angle that we can talk about is same side interior, or, and we'll get to it in a minute, same side exterior angles. So if we focus on the interior part of this definition, same side because both these angles are on the same side of the transversal. Interior because they're both on the same side of the transversal and they're both located in between the parallel lines. They're sandwiched between them. So the name is very literal. Same side, interior, inside. Now the relationship between these two, if we just look between these angles, they are not the same at all. One is an acute, it's small angle, and one is obtuse, it's a big angle. So they're not congruent to each other, but they are supplementary to each other. These two angles will always add together to be 180. Now, if we apply our idea of vertical angles that we just talked about to this, if this angle here has two arcs, that means this angle will also have two arcs. They're congruent to each other. And if this angle has one arc, this angle is also going to have one arc because, again, they're congruent to each other. Now, if my original two angles are supplementary, these two angles having the exact same measurement are also supplementary to each other. So, same side exterior is the exact same as same side interior. They're on the same side of the transversal. These are both on the bottom. They're both facing outwards away from each other, and the relationship is still that they're supplementary to each other. So these four types of angles are incredibly important to recognize and know how to work with when it comes to parallel lines cut by transversals. And so with that, we get into looking at our first problem. Angle 4 is 118 degrees, and we want to find the measurement of all the other angles. Well, if we look at angle 2, we have a pair of vertical angles with each other. So that means that angle 2 is congruent and also 118 degrees. If we look at angle 8, the relationship between angle 8 and angle 4 is corresponding angles. They're on the same side of the transversal, but they're facing in the same direction. And so because of that, that means that angle 8 is 118 degrees as well. And then if we look at angle 6, we have, here's a transversal, we have alternate sides, and they're both on the outside of the parallel line. So alternate exterior That means angle 6 is also 118 degrees. Now, if we continue talking about these blue numbers that we have, the relationship between 2 and 8 would be alternate interior because they're on the inside of the parallel lines. And the relationship between 2 and 6 would be corresponding. The relationship between 8 and 6 would be vertical angles. And the relationship between, I think I hit them all there. So then we can go into the orange one. Now the easiest path to travel is just to go from angle 4 to angle 1, or angle 2 to angle 1, or any of the adjacent angles that are next to each other. If we look, there's a straight line being formed and a ray coming off from it. This fits perfectly the idea of a linear pair, which means that angle 4 plus angle 1 has to equal 180. And because we know that angle 4 is 118 degrees, we'll call angle 1 x, and that allows us to be able to solve for that value of angle 1. So if we subtract 118 off to the other side, that tells us that x is 62 degrees. So angle 1 is 62 degrees. Angle 3 is vertical to angle 1, so it is also 62 degrees. Angle 5 is corresponding to angle 1, so it is also 62 degrees. Angle 3 and 5 are alternate interior angles together, and angle 1 and 7 are alternate exterior, so angle 7 is 62 degrees. And that now allows us to be able to say that we have every single angle determined. So as we continue on, this question says that angle 3 is 111 degrees, and angle 14 is 46 degrees. So it doesn't matter which angle that we start with. We can start with angle 3 or we can start with angle 14. I'm going to start with angle 3. I'm also going to change it to blue just so we can have some color coding going on. So from angle 3, angle 2 is vertical to it. So angle 2 is going to be 111 degrees. From angle 3, angle 10 is alternate interior. So it is 111 degrees. And angle 11 is vertical to 10. Angle 11 corresponds with 3. And angle 11 is alternate exterior with 2. So it is also 111 degrees. Now if we go look at 14, 15 is vertical with 14, so 15 is 46 degrees. Angle 5 is, or not 5, my bad, angle 6 is corresponding with angle 14, so angle 6 is 46 degrees. Angle 7 is alternate interior with angle 14. Angle 7 is also corresponding with angle 15, and angle 7 is vertical with angle 6. So angle 7 is 46 degrees. Now we can start looking at the other angles that have different degrees than 111 or 46. So if we jump back over to the blue side, angle 1, this is making a straight line together with a ray coming off, so 1 and 2 must be linear pairs, which means angle 1 is 180 minus 111, which gives us 69 degrees for angle 1. Angle 4 is vertical to angle 1, so it has that same measurement. Angle 9 is alternate interior with angle 4. Angle 9 is corresponding with angle 1, so it has the same measurement. Angle 12 is vertical to angle 9. Angle 12 is corresponding to angle 4, or angle 12 is alternate exterior with angle 1. So it also has that same measurement. As we look at the other side, we'll go from a different direction and not just rely on a linear pair, but we can see that angle 8 right here and angle 14 are considered to be same side interior because they are sandwiched between the parallel lines, and they are on the same side of the transversal that they're next to. So that means that angle 8 is equal to 180 minus 46, which is 134. And so because angle 5 is vertical with angle 8, it is also 134 degrees. Angle 16 corresponds with angle 8, so it is 134 degrees. Angle 16 is also same side exterior with angle 6, and angle 16 is alternate exterior with angle 5. Angle 13 is vertical to angle 16, so it's 134. It's also alternate interior with 8. It's also corresponding with angle 5. And so with that, every single angle is found. So as we start this problem, we see that we're given lines A and B and they're parallel, that the measure of angle 9 is 60 degrees, and the measure of angle 14 is 110 degrees. And so we need to find the rest of these missing measurements. So we only have two angles, but if we look between them, one is much easier to work with than the other just visually looking at it. And that one would be the 110. Because 110 only has these other three missing angles around it, whereas 60 has a whole lot more. So from 110, I would be able to see that straight across from it forms vertical angles. So 15 is vertical to 110, that angle 14. So then 15 is going to have the same measurement, 110. Which then, if we look at 16, 16 and 15 form a linear pair. They create a straight line underneath them. And so that means that to get 16, it's 180 minus 110, which gives us 70. So 16 is 70 degrees, making 13, because it's also vertical to 16, 13 is 70 degrees as well. So the question now is, where do we go from here? What can we use definition-wise to be able to apply and come up with our next angle measurement? Well, if we look at angle 12, this line is a transversal for these two parallel lines. Angle 12 and angle 16 are both on the same side. They're both on the bottom side of this transversal, and they're both facing the same direction. They're facing out to the left. So they're basically the same angle, just in different spots. That means it's corresponding. So because it's corresponding, angle 12 is going to have that same measurement as angle 16, so that means it is also 70 degrees. And if we look at just those two lines, angle 12 and angle 10 are perfectly fit between these two lines intersecting, which means angle 12 and 10 are vertical, which means 10 is also 70 degrees. Now as we look at angle 11 right here, we have a straight line, and all straight lines always have an angle measurement of 180 degrees. These three angles are all coming together to create this straight line. You have the angle 11 angle, the angle 9 angle, and the angle 10 angle. And the three of them are coming together to make that straight line. So it means that whatever measurement angle 11 is, plus 60 plus 70 must equal 180. So to get 11, it's 180 minus 60 plus 70, which gives us a degree measurement of 50 degrees. And so if we look, we're now inside of not only knowing the measurement of 11, but we're inside of a triangle. Now triangles, which should have hopefully been learned at some point, triangles, if you add up all three of the interior angles, so 8, 13, and 11, they should add up to be 180 degrees, always. So it means that 70 plus 50, if we take them off of 180, we get 8. Well, if we look back, these three together are those same measurements. So if we have 50 and 70, if we subtract them from 180, it should give us 60. So 8 is 60 degrees. The other way that we could have gotten that is 9 and 8 are, if we look at our lines here and our transversal, they're alternate interior angles. So we could have also gotten 8 by applying our parallel line definitions. Now from there, 5, we can see that these are also two lines intersecting, which makes 8 and 5 vertical to each other. So 5 is also 60 degrees. And now if we go back over to 10, this 70 degrees right here, if we look up, we see what is basically the same angle as well. 1 and 10 are corresponding to each other, so 1 is also going to be 70 degrees. Which then, because 1 and 2 are forming a straight line together, they must have a measurement of 180 degrees, which means 70 minus 180, or 180 minus 70, gives us 110. So that's where angle 2 comes from. And then because 1 and 3 are vertical to each other, 3 is going to share that same angle, so it's 70. And then again, we're inside of another triangle. So we have two angles, 70 and 60. All three must add to be 180. So 180 minus these two, we've already done it here in blue. That gives us 50 degrees. And then also, like we've said before, we have two parallel lines cut by a transversal. 7 and 11 are alternate interior angles. So that's another way that you could have gotten to 7. So from there, we see two lines intersecting. These two lines, 7 and 6 are perfectly fit in between those two lines, which means they are being formed by them, which means that 6 and 7 are vertical, which means 6 is 50 degrees. Always, if you're unsure whether it's vertical or not, always just draw out the two lines and see, does your angle fit perfectly between those two lines? If it does, it's vertical. If it doesn't, then it's not vertical and you need to move on to something else. So lastly, 6, 5, and 4, they all together add up to be 180. So 50 and 60, 180 minus 50 and 60 gives us 70. And that's all of the angles answered. So it's not a foolproof, if you do X, Y, and Z, you're always going to get the answer. It's more of a, let's start at a point and just see where can I go. I started at angle 14 because it looked the easiest, and I just said, where can I go next? And once you get there, say, where can I go next now? So for this question, we want to find the values of A, B, C, and D. If we start with A, because it's right next to a number, the relationship here, it looks like, is linear pairs. So that means that 46 and A together must add up to be 180. So then 180 minus 46 is going to give us that A value. Which is going to be 134. So A equals 134. Now if we look at D, there's two different ways to get to D. Way number one is we have two parallel lines and a transversal cutting through it. A and D must be supplementary. They are same side interior angles, supplementary. The other way that we could get to it is, again, parallel lines cut by a transversal. 46 and D are alternate interior angles. Either way that you go, D is going to be 46 degrees. And then as we go and look at B, it's the same idea. We have two parallel lines. They're being cut by a transversal. So B and 77 are alternate interior angles. So B equals 77 degrees. And lastly, 46 is vertical to this inside angle. 77, which is what B is a vertical to this inside angle. And then we have a triangle. So C is equal to 180 minus 46 plus 77, which equals 57 degrees. So C is 57. So now we want to look at Tyler and figure out what error he made. Tyler says that x equals 72 degrees, so this down here, by same side exterior angle theorem. So Tyler is correct to use the same side because these angles are on the same side of that transversal and their exterior. They're both facing outwards away from the parallel lines. But the issue that Tyler ran into is that they are not congruent. Same side angles, same side exterior angles, are supplementary to each other. So it should not be 72 degrees. It should be 180 minus 72, which is 108 degrees. That is what Tyler should have been saying that this x value was equal to. In the parking lot shown, all of the lines for the parking spaces should be parallel. Angle 3 is 61. What should the measurements of angle 1 and 2 be? So if they're all parallel, what we can kind of do if we need to help visualize this easier is we can extend these lines out and really look at it as lines, parallel lines, and transversals. So if this angle is 61, because we're dealing with parallel lines, that means angle 1 is related to it. And we'll even do this in a different color just so we can see it a little easier. Angle 1 is related to it. These two angles are corresponding to each other. So that means that angle 1 must also equal 61 degrees. And so from there, we want to find angle 2. Well, there's two ways to get it. First way is we look at the fact that we have two angles that are inside of parallel lines and they're on the same side of the transversal. That makes them same side interior. And so because they're same side interior, 180 minus 61 would equal angle 2, which is 119 degrees. So angle 2 is equal to 119. The other way that we could have gotten that number, if we didn't recognize same side interior, would be to recognize that these two angles are supplementary. And so 180 minus 61 would equal this angle. And then from there, it corresponds with angle 2. So we could have jumped from there over and gotten the measurement for angle 2. So either way you go, you should still be able to come up with the same numbers. The black trim shows the black trim shown for the wall of a barn should be constructed so that AC is parallel to EG. So AC is parallel to EG, and JA is parallel to HB, and then JC is parallel to KG. So these two horizontal slots are parallel to each other. So then from there, the question is, what is the measurement of angles 1 and 3? And I'll say, and angle 2. So if we look at angle 2, we have a pair of, because it's parallel lines cut by a transversal, we have a pair of corresponding angles. So the measurement of angle 2 is just 68 degrees. Now, to get to angle 1, angle 68 degrees would be the same because, again, we have corresponding angles here. And then angle 1 and this angle are supplementary. So angle 1 is 180 minus 68, which is equal to 112. The other way that we could have gotten it is we have same side interior angles, and so they would be supplementary to each other. Either way, you should be able to get that same number as 112. So lastly, we have angle 3. So we know that this angle here is 68 degrees because it was corresponding with A. It is also corresponding with angle 3. And so from there, angle 3, we can easily say, is 68 degrees. A transversal intersects two parallel lines. We have no diagram, so that should be enough information to let me know that, hey, I need to draw this out. So a transversal is intersecting two parallel lines. The measure of a pair of alternate interior angles, so these angles here, is 5V and 2W. The measure of a pair of same side interior angles is 5V, so the same angle we're looking at here, and 10W. What are the values of W and V? So this is the setup that we're looking at. And so the question is, how do we even get started here? Well, if we look at the same side interior, 5V plus 10W has to equal 180 degrees. If we look at the alternate interior, 5V must equal 2W. And if 5V is equal to 2W, then 2W can be substituted in for 5V. And the reason why we do this is because 5V plus 10W, that means nothing to me. But 2W plus 10W, well, that can be combined. You get 12W is equal to 180. And then you would divide your 12 from there, and you would get W is equal to 15. And so because W is equal to 15, 5V plus 10 times 15 equals 180. 10 times 15 is 150. 180 minus 150 is 30. 30 divided by that 5 gives us 6. So all of that is ways that we can work with lines cut by, or parallel lines cut by transversals. What if we don't know that they're parallel lines, but we know some stuff about them? That's where we kind of go in the reverse. So the converse theorems is that converse corresponding, if you have two lines in a transversal and the corresponding angles are congruent to each other, then the lines must be parallel to each other. Converse alternate interior, if two lines in a transversal form alternate interior angles that are congruent, then the lines must be parallel. Converse same side interior, if two lines in a transversal form same side interior angles that are supplementary, then the lines are parallel. And lastly, converse alternate exterior, if two lines in a transversal form alternate exterior angles that are congruent, then the lines are parallel. So I'm going to kind of fast through these because they're a little straightforward. If what we already know, like these kind of angles corresponding alternate interior, if they're coming out to fit the definition of what they should, the angles are congruent for the ones that need to be, or they're supplementary for the other ones, if that statement is true, then by what that thing is supposed to be saying, by that definition, by the fact that corresponding angles are congruent for parallel lines, then the lines must be parallel. That's all these are trying to say. If it happens the way it's supposed to, they're parallel to each other. So we go and we read a problem like this and we apply that idea. If angles 1 and angles 2 are congruent, so this line or this symbol means congruent, equal, then by the converse of the same side interior angle postulate, those lines, L and M, must be parallel. Well, what's the error here? The error is that same side interior does not mean congruent. Same side interior means supplementary. And so the fact that they are congruent means nothing. Angle 1 could equal 89 degrees and angle 2 could equal 89 degrees. That means that eventually these lines are going to cross each other. So the fact that they're congruent means nothing. It's that they're supplementary to each other. That is what defines those lines as being parallel. So to make it a little bit more exact in how you could explain it, angle 1 and angle 2 should be supplementary to each other for the lines to be parallel. And then lastly, we have if angle 1 and angle 2 are congruent, which theorem proves that line C and D are parallel? Well, angle 1 and angle 2 are sandwiched between C and D, and they're on opposite sides of the transversal. So that is the converse alternate interior theorem. And if angle 2 is 4x minus 6 and angle 3 is 2x plus 18, what value for x would prove that A and B are parallel? So if we're trying to prove that A and B are parallel, then angle 3 and 2, alternate exterior angles, they must be equal to each other. So 4x minus 6 is equal to 2x plus 18. And so we would subtract the 2x, giving us 2x minus 6 is equal to 18. Add the 6. 2x is equal to 24. Divide the 2. X is 12.